You've probably seen some version of this image online. A field of sunflowers, the Chernobyl reactor right behind them. The caption's always the same. Scientists planted these and the radiation went away. Here's the problem. That's not what the records actually describe. It's a good story, though. That's the trouble with it. Technology poisons a landscape, and nature answers back with a flower. It's simple enough to feel almost inevitable. So the actual experiment happened in the mid-1990s, on a pond, not a field, a contaminated pond near the reactor. Researchers floated a raft on the surface. Sunflowers grew up out of it, stems in the air. Their roots hung straight down into the water. Hold on to that detail, everything else depends on it. The method's called rhizofiltration, root filtering. A normal plant pulls nutrients through soil, slowly over time. This is different. You skip the soil entirely and put a dense mat of roots directly into contaminated water. There's no drama to it once you strip away the mythology. A frame holds the plant above the surface. Below it, a curtain of pale roots spreads through dark water. Nothing changes color. Nothing flashes when a caesium atom reaches the root surface. The pond doesn't announce anything. You only know it worked because someone tested the water afterward and tested the roots. From a distance, it looks like a garden. It's actually an instrument. Two isotopes were the targets, caesium-137 and strontium-90. The reports say the root system concentrated both from the water. That much checks out. What doesn't check out are the numbers attached to the story later, precise percentages and dramatic removal rates, some borrowed from a different study entirely, one involving uranium-contaminated water in Ohio. Strip those borrowed numbers away, and something smaller but solid remains. Roots in contaminated water collected enough radioactive material for researchers to take the method seriously. Here's what that doesn't mean, though. Collecting a contaminant isn't the same as destroying it. A sunflower can't make an unstable atom stable. If caesium leaves the water and ends up in the root system, it hasn't disappeared. It's just moved. That's why the most important moment in this whole experiment wasn't the planting. It was the harvest. Once harvested, they looked for a moment like a crop. They weren't one. You couldn't compost them or throw them out with the yard waste. The sunflowers had to be handled and disposed of as radioactive waste. The flower became the container. None of this makes the experiment a failure. Taking something spread thin across a pond and concentrating it into a bundle of roots you can control, that's the actual win. That's the basic bargain behind filtration. Something gets cleaner because the captured material gets more concentrated somewhere else. The trick is controlling both sides. But that second half, the concentrated, contaminated part, rarely survives the retelling. And the story didn't stay in the pond. If roots could collect radionuclides from water, the logic went, surely fields of them could pull contamination from soil too. Fukushima in 2011 gave that idea a real field test. This time, the roots weren't hanging free in open water. They had to push into soil and find the contamination there. That's a completely different job. In water, accessible ions can move around a root surface. In soil, radiocaesium can bind tightly to clay and mineral sites. A root can grow right beside it and still gain almost no access to it. The sunflower didn't get worse at its job. The ground changed what the roots could reach. Japanese researchers tested sunflowers alongside amaranth, sorghum, and buckwheat across 2 soil types. All of them took up some radiocaesium. But the fraction actually removed from the field, the number that would matter for cleanup, was tiny. People treat Chernobyl and Fukushima like they contradict each other. They don't. They're answers to 2 different questions. Can sunflower roots collect accessible radionuclides from water surrounding them? The Chernobyl-area pond test indicated that they could under those water conditions. Can a field of sunflowers remove a meaningful share of radiocaesium bound within the soil? Under the tested Fukushima conditions, barely. Same plant, different medium, different answer. So how does a pond experiment turn into a story about a field? Maybe it's just easier to repeat the short version. Maybe nobody along the way meant to mislead anyone. Drop a qualifier here and a detail there, and roots in a pond concentrated 2 isotopes becomes sunflowers cleaned up Chernobyl. Not a conspiracy, a compression. And the compression had help. Sunflowers already mean warmth, resilience, and movement toward the light. Put that image next to a reactor, and it explains itself before anyone checks a single fact. Most disaster stories don't get an ending. Reactors, exclusion zones, contaminated water, radioactive waste, these things stay open and unresolved for decades. A Sunflower closes the story anyway. It turns an engineering experiment into a scene of recovery, even though what actually happened was a transfer, and the transfer ended in a waste container. The real version doesn't offer that ending. It asks you to follow the flower down into the water, past the roots, and keep following even after the plant's pulled out. Less satisfying, more accurate. Did sunflowers clean up Chernobyl? No. The experiment didn't clean the wider site or its soil. But in one small pond near one reactor, sunflower roots did help concentrate caesium-137 and strontium-90 from the water. That part's true. Just smaller than the image. One more look at the pond. Above the surface, the flower everyone remembers. Below it, the roots holding material that had moved but hadn't disappeared. Until next time, enjoy the flowers and let someone else check the radiation levels.